All right, hi everyone. So if you're watching this, it's the morning of January 16th. Hopefully you've read the instructions for the e-learning work. It's basically just gonna be the first two pages of the notes for days 5 and 6. So first page looks like this. It's your typical warm-up. So I would say just pause the video now, try it out. Really don't spend more than like 3 to 4 minutes on this. And then you can come back and unpause, and then we'll kick it off. All right. So hopefully you are now unpausing. Don't just roll right through it. Actually, like pause and do the warm up. But I'm just going to give you some answers real quick. Um, let's see. 1/4 to the first is easy. That's 1/4. And then if you were to square, that'd be 1/16. This would be 1, reciprocal 4, reciprocal squared 16. So those are your answers for the green. Um, Answers for the yellow. Determine three ordered pairs of the function f of x equals, 1/4 to the x plus 1 and then plus 3. I'm looking at this exponent right here to figure out values I think would be useful or easy to evaluate with. So for example, over here, right, I immediately latched onto 1 as being an easy exponent to work with. 0, I think for sure is a good one. I think you kind of have your pick. Do you want to go for a reciprocal? Do you want to go for a square? Knowing that I have to do more stuff with this fraction after the fact, I think I'm going to want to use a reciprocal just to get a nice integer value. So let's say that I want this exponent to be -1, 0, and 1, right? That's going to be the exponent. And if I have x plus 1, right, that would mean that I need the x value to be -1, right? Because if I were to add 1, then I get to 0. Um, and then looks like I would want 0 for my x value, right? If you sub in 0 here, you'd have an exponent of 1. And then, just follow the pattern. This would be -2. We've done this before. This was back in Unit 5 when we were doing radical functions. I don't know if we gave a name to this. Some people call them smart points, quote, quote. Really, it's just sort of like think through what x values you would want to evaluate with. Because right now, all we have to do is come up with 3 ordered pairs. So I'm going to go with these -2, -1, and 0, right? And so then we have f of -2, right? That's our x value. That's to the 1/4, -2, plus 1, plus 3, -4 to the negative first plus 3, 4 plus 3, and that would be 7. Right, so f of -2 is equal to 7. We can do that again with -1. So 1/4 to 0 would be 1, plus 3 would be 4. So f of -1 is equal to 4. So our last x value is going to be 0. So 1/4 to the 0 plus 1 plus 3. 1/4 to the first would be 1/4. Then plus 3. I'll just convert to a decimal for this. Say 3.25. Right, so f of 0 is equal to 3.25. And the original prompt said give 3 ordered pairs. So I do want to write these just sort of as ordered pairs. So -2, comma 7, -1, comma 4, and 0, comma 3.25. All right, I'm going to skip over this red problem for now, just because, hey, it is red, it is spicy. So if you're trying this, hopefully you can also check your own answer after we do some of these problems. But also because if you remember, we used this technique, the smart points technique, when we were graphing, right? You had to come up with some points to make a graph, and that's really what we're going to do today. So I'm going to take these ordered pairs, copy them right now. And I'm going to bring those down to the top of page 2, where you'll notice we're actually going to graph that function that we were just working with. Right, so I'll even add a note here. Use technique from page 1. Right? If you were doing this fresh, you'd be looking at this function. You'd be saying, okay, what are some x values that are going to help me find some points? You'd be getting some points, and then we're going to plot them along with some other key features to make our graph. And I'm going to tell you here, when we are graphing exponential functions, I highly recommend that you use 3 points, right? The directions are going to say 2. If you talk to tutors or friends, they might say, well, I'm only doing 2. As I've said before, I think for previous units, getting that third point is really not that much time, and it does pay off just sort of as insurance to make sure that you're actually getting the right shape. I have seen it happen where people put 2 points, they have the correct asymptote. We'll talk about that in a sec, and they still make the wrong graph. So when you have 3 points, it's much harder to mess up the shape of the graph. You'll notice up here, once you get practice down, this process for each individual point probably takes you like 30 seconds at most. I really think it's a worthwhile investment in terms of time to just get that third point. So recommend 3 points here. All right, so I'm just going to go ahead and plot these points real quick. So let's see, I want to go as high as 7. I'll just make it 8 for nice scaling. And then let's call that 8. 4, this would be 6, this would be 2, and then that would be like -2 here, so that'd be -1. -2 comma 7 would be right here. We have -1 comma 4 would be right about there. And then 0 comma 3.25 would be right about here. Okay, so obviously we are not seeing the entire curve. We're only seeing 3 points. If I had to make a guess as to, well, okay, I'm not guessing. I know what it looks like. If you had to make a guess as to what the shape of this graph is going to be, I would hope that at a minimum we could sort of just connect these 3 points in the shape. Right. The question is what is happening outside of those points? And we could spend a lot of time sort of evaluating more points and just plotting things out and then just connecting the curve. At this moment, maybe just think a little bit about it though, right? Basically, if I were to go just 1 point over, let's say where x is equal to 1, right? I would have 1/4 to the second, which would be 1/16 plus 3. So 3 and then 1/16. We do that again, it'd be 1/64. 3 plus 1/64. Do that again. We're going to basically, as x keeps increasing, we keep making this fraction smaller and smaller and smaller and smaller, right? But the 3 stays the same. So we're never exactly equal to 3 because this fraction right here, right, is never really equal to 0, but gets very close to 0 as the exponent gets larger and larger, right? The effect of that is what we call asymptotic behavior, right? So an asymptote is basically a line that the curve of your graph gets really, really, really close to as you sort of go in a certain direction. So in this case, right, as x gets larger and larger and larger approaching infinity, the curve of the function is going to get closer and closer and closer to the asymptote, right? Because, as we saw, right, you have this constant of 3, which will always remain 3, and this exponential, which is getting smaller and smaller because the base is 1/4. All right. So the asymptote here is, well, let's see if we can catch this. It's not 3. Think for a moment as to why. This is, the moment in class where I'd be like, someone tell me why this is wrong. Think for a moment. If you said that the asymptote should be y equals 3, great job. Yeah, asymptote is a line. You need to write an equation for your line, right? Same way it was for the axis back in unit 3, right? The asymptote is a line. You have to write an equation for your line. Also worth pointing out, this is how you spell asymptote. So it's typed up for you. Don't spell it wrong in the future. Okay. Let's get the other side of this graph, and then we can fill out some other key features. So then, we talked about what happens as the graph moves to the right. Begs the question, what happens as the graph moves to the left, right? As x gets smaller and smaller, right? Well, we saw up here with this base of 1/4, right? As your exponents get more and more negative, the outputs are going to get larger and larger and larger, right? That's because we have a base of 1/4, but the negative exponent is giving you that reciprocal. So you're really taking 4 and then squaring and cubing and taking to the 4th power, right? The effect of that is that as x gets super, super negative, right? Let's say x was negative 100, right? That 1/4 taken to a reciprocal of then 4, and it takes to the 99th power, that'd be a super big number, right? And then you just add 3 on top. So really what's happening is that these y values are going to get larger and larger and larger very, very rapidly. That's where the phrase exponential growth comes from, right? Or if you say something was, growing exponentially, before you had any exposure to that in a math class, you probably heard that as meaning just growing really quickly, right? That's really what this is you can see the curve sort of just takes off as we move off to the left, right? And that also gives us some language that we can talk about as it relates to the curve and the asymptote. On the right-hand side, I would say the curve converges to the asymptote. Right? Converges just means like gets close to. And on the left, I would say the curve diverges from the asymptote. Right? Diverge is meaning get away from. Right? So there's some vocab for you. In terms of domain, we've basically finished everything we need for the graph. You can maybe see that the domain is negative infinity to infinity. That'll be your layup for this unit, that the domain of any exponential function is going to be negative infinity to infinity. Remember, layups are easy, but they're not guaranteed. Don't miss your layups. For the range, 3 comma infinity, right? Taking the minimum y value and the maximum y value. Infinity always gets a parentheses. Think to yourself for a moment as to whether that 3 is going to be included with a bracket or excluded with parentheses. Excluded with parentheses is the answer that we're looking for here, right? Because as we said, right, the curve will get very, very close to the asymptote, but never actually get exactly to 3, because this exponential never really equals 0, right? So we're excluding that 3 there. And then in terms of end behavior, it's been a minute since we wrote end behavior, isn't it? But hopefully it comes back to you. As x approaches negative infinity, will this be f of x? Well, since f of x approaches infinity, right? Because as x approaches negative infinity, moves to the left, the curve has increasing y values. And then as x approaches infinity, f of x approaches 3, right? As x approaches infinity, the curve gets closer and closer to 3. All right, so that'd be your behavior. So there you go. That's one problem. I will do the second problem just real wicked quick, and then I'm going to call it there because this video is not supposed to be longer than 20 minutes, folks. I guess I didn't even build in time for you already doing your warm-up. Oh my goodness. Let's do this quick. So, I want g of 5, that's for sure, and g of 6 I think would be good. And let's just go for g of 4. That feels good. Basically what I'm doing is taking the 5, so that 5 minus 5 is 0, and just going up 1 and down 1 for 4 and 6. I guess 6 and 4, the way I said that. Anyway. 4 times 3, 4 minus 5 is negative 1. So 4 times 1/3 would be 4/3. 4 times 3, 5 minus 5 is 0. So that'd be 1 times 4 is 4. And we got 4 times 3, 6 minus 5 is 1. So that would be 12. All right, in terms of an asymptote, Hopefully you picked up on the previous problem that the vertical shift, right, that constant we add on the end tells you where the asymptote is. For this, we don't have a constant on the end. We don't have a vertical shift. Or really, if you think about it, that'd be like plus 0. So y equals 0, I'm going to say is the asymptote. Domain we talked about was a layup. Range at this moment, I would say you maybe need to graph in order to get a sense of. But eventually you're going to pick up, oop, I was wrong, over time, how to notice the pattern. We'll talk about that at a later date. 0 to infinity. Actually, I could do this now. I can do that behavior now. I guess this is the challenge. This is the extension. Figure out how I'm determining the range in the end behavior without actually drawing the graph. That would be 0. And as x approaches infinity, g of x approaches infinity. All right, so now we're going to graph. Hopefully that lines up. If this, my graph doesn't match my end behavior in my range, that will be embarrassing. Okay. So 4 4/3, be a little more than 1. Oh, come on, man. 4, 4/3. My other point was 5, 4. Like here. 6, 12. Asymptote at y equals 0. Also, folks, you can make these curves in more than one motion. Notice, hey, I'm going to pick up the pencil. Stop there. Actually, that's not even that good. I can do better. Hold on. Basically, some people try to do these curves in just one movement, and it ends up not looking that great. So I'll stop there, and we'll throw a tail there. And then I'll come down here, pick up again, follow the asymptote. Range was 0 to infinity. Cool. And my end behavior looks good. Was correct. Awesome. All right. That is it for today. So make sure that you get your notes submitted in Canvas. That's what I'm going to use to check your attendance. And see you tomorrow? Question mark. Fingers crossed. All right. Bye, folks.